All right, WHS, here we go again. We are going to talk today about linear equations, and in particular parallel and perpendicular lines and what their graphs look like, and in particular what about their slopes. Okay, so pretty simplistic lesson, I think. One of the things you want to try to remember is your linear equation forms. If you have y by itself and there's no power in an equation, it's going to produce a line of solution points. And that was called slope-intercept form, or y equals mx plus b. So if I asked you guys in this first equation here, what is the y-intercept, I'd hope you'd say, Mr. Kohler, it's at positive 1 where it hits the y-axis, and then this here represents the slope, the rise and run from there. So let's graph this first linear equation, and then we'll graph the other one and take a look. So y equals 2/3 x positive 1, so not to be redundant here, but the y-intercept is positive 1. And the slope is 2/3, so rise 2 and run 3. And 2 points determines a line, and we can graph that. Let's try that again. Apparently I didn't get the right breakfast cereal, and my hand motion must be off a little bit here this morning. But there's that one. Now I want to graph the second one. Y equals 2/3 x minus 2, so the y-intercept is at -2 this time. And the slope, again, is 2/3. So rise 2 and run 3. And I'm just wondering, we could talk about this ahead of time, what do you think is going to happen if the slopes are the same with your lines? And I hope you'd say that the lines will never cross, which means they're going to run parallel. If you change the slope of one line at all, just a little bit, eventually those two lines will have to cross. These are the same slopes. Those lines are going to run parallel. Okay, so what we need to know is parallel lines have equal slopes. Okay, all right, good. Now going to the flip side over here, these are not equal slopes. They are going to intersect, but let's look at how they're going to intersect. So let's graph the first one. The y-intercept's at -2. This slope is positive 3/4, so rise 3, run 4. And that looks like that would be the line for the top equation. Second one, -4/3 x positive 1. The y-intercept's at positive 1. This one's going down 4 over 3. And I get intersecting lines like I promised. All right, now, what's the deal here though? Not only are they intersecting, but if your mathematical memory kicks in, they're intersecting at a 90-degree angle, which means they're called perpendicular lines. Okay? So parallel and perpendicular lines are kind of special lines used all the time in math. And if you look at their slopes, what I want you to see here, what about their slopes? Well, oops. They're not reciprocals. You do flip the fraction, but you also have to change the sign to make it this is what's called a negative reciprocal fraction. Okay, so that's what you need to know. Perpendicular line slopes are negative reciprocals. Parallel line slopes have to be the same. Okay? So this is the idea we're going to work off of with this little lesson. So I can take a note. Parallel line slopes are the same. Perpendicular line slopes are negative reciprocals. So if I had a slope of A over B and you said my line's perpendicular to yours, Mr. Kohler, you'd have to flip that and change the sign. It would be negative B over A. So once you get the hang of that, that's pretty easy. So if my fraction was 3/7, the perpendicular slope would be flip it and change the sign to negative 7/3. If mine, watch this, if mine was 4, and you said I got the perpendicular line slope, well, you'd have to put a 1 underneath that, flip it, and change it to be negative 1/4. Okay? Just be careful on that. If I said my slope is 1/2, and I want the reciprocal slope to that, or the perpendicular line slope to that, it'd be negative. You flip that, and you'd have 2. All right? So, there you go. All right, let's go ahead and look at some problems with that then. And look what I just did. I ended up answering my question before I went to the next slide, and I'm pretty good at that. So, here's a table. I give you a slope, and I want the parallel line slope, and I want the perpendicular line slope. Parallel lines have the same slope. Very good. Perpendicular line slopes are negative reciprocals. All right, so 4/5 parallel, 4/5 perpendicular, negative 5/4. Okay? Negative 2/7 parallel, same slope. Perpendicular, flip it and change the sign, positive 7/2. 1/2, parallel, 1/2. Negative reciprocal, negative 2. Negative 4, parallel, same slope. Perpendicular, flip it, make it the opposite sign, positive 1/4. Negative 1/3 parallel, negative 1/3. Perpendicular, flip it, change the sign, positive 3. Okay? So there we go. We should have that now for the rest of our lives, correct? Okay. All right. So on the MCA or on the state or the grad portion of the MCA, they may ask you, okay, which lines are going to run parallel or perpendicular based off the equation. Okay? So here I've got choose an equation for the line perpendicular to each shown. All right? So I've got 4 equations here and to choose from, and I've got a couple different lines. So what you got to be able to do is look at the line first and identify what that slope is. Okay? That is going to tell you what you need to know, because parallel lines are going to have comments the same slope, perpendicular, negative, reciprocal. So let's look at line B. And what you kind of want to do, folks, is look for a couple of spots where the line hits corners so you can for sure get the slope right. I look at this and I see a corner point there, I see a corner point there. I'm seeing rise 3, run 1, so the slope on that baby is positive 3. Okay? So if I'm looking at these set of equations, I want a parallel one and a perpendicular one. Parallel has the same slope. So I'm going right down here, looks like right here would be parallel to that line right there. Okay? Now if I was going to say perpendicular to this one, the slope of the perpendicular would have to be negative, flip it, 1/3. So I'm looking at, right here, this one would be perpendicular. So this line B here, I guess my choices were down here. Okay? Alright, so line A, I must be looking at this grouping. But again, you got to find your slope to be able to look for the slope you're looking for in this particular problem. So this slope is negative. Take a couple corner points, corner point, corner point. I'm going down 2/4. So negative 2/4, which reduces to negative 1/2. Parallel, same slope. You would be you. You would be the parallel line to that. Okay? And in fact, rather interestingly enough, I think it's the exact line. Oopsie daisy. Alright, perpendicular to it, flip it and change it to its opposite sign, be positive 2. The only one there would be right here, perpendicular. Okay? So good little questions to indicate which lines would run parallel, which lines would be perpendicular. I suppose we could graph all these to see it, but it's not necessary. The slope tells you how a line is slanting, and you can determine whether it's parallel or perpendicular just based off its slope. Okay? Alright, the last thing here says write an equation for a line parallel to the one in A. Okay, well, if they're referring to this line here, and if it's parallel, it must have the same slope. And our slope here was negative 1/2, wasn't it? So you can make any equation. I put it in slope in form. Slope is negative 1/2. I don't care. I could just leave it like that. Okay? Write an equation for a line parallel to B. Well, okay, B was here, and that had a slope of 3/1. Parallel again. So, just has to have the same slope. Okay?